We are going to get started. The session will be recorded. Hello, and welcome to Sterling and VMware's Power Block session. I'm Megan Moore, Sterling's VMware Partner Business Manager. We know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is of the utmost importance here at Sterling. We have a robust secure supply chain, including OTIPS and CMMC certifications. For any questions about Sterling, please use the email aliases you will find at the end of the demo. For questions during the demo, please put them in the Q&A feature at the bottom of your screen, and we will address them at the end. Now, I will turn it over to Cloud Architect Billy Downing to demonstrate NSX-T Advanced Load Balancer for multi-location VDI.
Awesome. Thank you, Megan. So like she said, my name is Billy Downing. I'm a cloud architect here at Sterling. I'm part of the cloud architecture team of our strategic services organization. And so what we're going to talk about today is we're going to talk about Horizon in a multi-site environment and how we're going to accomplish that multi-site environment in regards to load balancing as well as policy instantiation across. We're going to talk about NSX-T Federation and the NSX Advanced Load Balancer, also referred to as AVI, as the company that VMware acquired for that capability. I'll use those terms kind of interchangeably as far as Advanced Load Balancer and AVI, so just be aware of that. So first, we'll do a quick overview of what those 2 different products are and how they kind of integrate together. Then we'll do an architecture review of AVI specifically, and then we'll actually do another one for NSX-T Federation and how that actually looks in the environment. And then we'll go ahead and jump in and see how I built this out and how you could too, if you have a solution that you are attempting to provide in your environment. So the first component we're going to talk about, and again, the emphasis of this talk is mostly about the infrastructure to support Horizon and less about specifically what Horizon is and how it actually accomplishes this. But for an overview of Horizon, just to level set, the 3 main components that we have to be aware of are going to be Workspace ONE, the unified gateways, and the connection servers. If you look at the diagram kind of from top down, we can see how these different tools are utilized in the chain of accessing a virtual desktop infrastructure. And like I said, the end goal here is really to provide Horizon to provide the solution that you can use to have remote capability for your consumers, whoever it is you're providing access to your data center through a thin client or whatever their device they're using, that you can then use to access directly into your data center. The benefit here is that when users are consuming resources directly in your data center, using resources that are inside your data center, you have the utmost control over what they can and cannot do. The webinar that we did last week was specific to NSX-T and the identity-based firewall in the same solution. So we won't touch, I can touch on that, but that won't be a focus of today. But what I'm trying to get at is that we can use Horizon to get this virtual desktop infrastructure up using Workspace ONE for a self-service catalog of applications to kind of dictate what users can and cannot do, or what they cannot access when they're in the environment. We can use the unified gateway, which acts as a proxy for users on the outside internet or outside of your environmental control, to act as a proxy for user connections into the VDI environment. And then finally, we have the connection servers, which is kind of that bridge between your user, the interface that they'll actually be seeing when they're determining when they're going to connect to a VDI desktop to start doing their work. NSX-T and AVI fit into this picture as providing the ingress and egress as well as security policy for this entire environment. So in my environment, I have NSX-T 3.1 and AVI 20.1, I believe. And we're going to be seeing how we can load balance 2 different Horizon clusters across multiple sites using Avi with GSLB, so to be hosting some DNS features and things like that. And then using NSX-T and its federated capability to have policy go across both sites so that we can make sure we lock down these VDI instances from that perspective. So now we'll take a look at just kind of the overview of what is NSX-T for data center and what is the advanced load balancer and what functionality does that bring in addition to NSX-T itself. The first point I want to make is that these two products are not mutually inclusive, meaning that you can have a deployment of Avi without using NSX-T, and likewise, you can do a deployment of NSX-T without deployment of Avi. These are kind of the product sets that work better together, but they are not necessarily required for one another to be deployed in any sort of environment. So if you look for Horizon or any sort of infrastructure you're deploying, you'll find reference architectures that include both NSX-T as well as Avi, and some of them that are exclusive to one of the other product sets. So going from kind of clockwise, starting at control and management, the reason I group these together for NSX-T as well as Avi is that they have a very similar architecture when it comes to deployment, as well as management and configuration of the environment. So if we talk about control and management, they both have a centralized, highly available controller cluster that is made up of 3 nodes in a highly available cluster. 3 nodes is the kind of the zookeeper methodology of maintaining quorum across your management and control plane suite. And so what this means is that you're disaggregating your control plane from your data plane. So any issues that exist in your control plane, or we can look at it as your single source of truth, will then be implemented down into your data plane so that those things are mutually exclusive in a way that impacts for your control and management, such as upgrades or outages, don't necessarily impact the data flow of your actual user traffic as it traverses your environment. If we go down a little bit and we take out what is the data plane, since it is abstracted from the control plane, we have virtual instances that are going to be managing these nodes from an NST perspective, NSX-T perspective. The data plane is going to be made up of transport nodes, which can be either KVM host or ESXi host, as I have labeled here, and will be in my environment. And for Avi, we'll be looking at the concept of service engines, which are actually going to be the instantiation of actual load balancers in your environment. These can be on top of virtual environments. These can be on top of clouds, any sort of public cloud that you're interested in, whether that GCP, AWS, or on-prem in vSphere, or a simple Linux host if you need bare metal load balancing as well. And that'll make up kind of the data plane for the environment. So those two different assets, the ESXi hosts or transport nodes for NSX-T and the service engines and all that goes in them from Avi will all be controlled and managed by a central control cluster, providing kind of that disaggregation between control plane and management plane and your data plane. From a security framework perspective, if you look at it from NSX-T, we're looking at it from a holistic network perspective. So your entire fabric and how you're going to secure that fabric. Specifically, NSX-T does very well in east-west traffic flows. So we're talking about traffic that could potentially be in the same exact subnet, where today in a traditional environment, in order to accomplish layer 7 or layer 4 and above firewalling between assets in the same subnet, you would have to hairpin traffic to an external firewall, which could then become a bottleneck in your topology. And that's something that, because an NSX-T does have a decentralized data plane using all those transport nodes, the resources used for firewalling is going to be scaled with however many transport nodes you apply in your environment. So every time you add a new host and you add it to the NSX-T fabric, it's very similar to adding new resources for your networking functions. And Avi functions in a very similar way. Specifically, Avi focuses on application entry point security for whatever you're hosting or your load balancing into your environment. So what Avi is going to focus on is that aspect of entry into your environment. So we're going to employ security policy on our virtual IP addresses that exists on our service engines. And we'll take a look at what this architecture means and kind of define some of these terms. Especially, it'll make more sense when we look into the actual environment. But any of the typical load balancing functionality that you would be using today and any of the competitors, is the same thing that Avi can accomplish. The big difference with Avi is again, that decentralized data plane kind of coupled with that centralized control and management plane. So we can talk about things like the WAF, web application firewalling, and other network security policies that we can implement using Avi, and how that also integrates into different cloud environments as well as vSphere and on-prem. So from a services framework perspective, NSX-T is going to provide generally all of your network functions that you would expect out of your hardware top of rack switches. And essentially what NSX-T is going to do is provide that software networking, software-defined networking overlay on top of your existing hardware platform. So what that allows you to do is simplify your underlay or your physical top of rack switches in your physical environment. You can greatly simplify that so you don't have to buy such complex switches and routers, and you can place that complexity into NSX-T, so you can kind of move those different objects such as your BGP daemons or your DHCP or things like that, or routing and switching down into NSX-T rather than having to rely on a complex underlay environment in your physical topology. Avi does something very similar. But the way that Avi integrates within NSX-T is it provides this advanced load balancing functionality. And what that actually comes down to as far as advanced load balancing is that it has feature parity with a lot of the top vendors that you might be familiar with today. So it adds that additional functionality to NSX-T if you have an NSX-T deployment, or Avi can be deployed as a standalone load balancer for your entire environment. So some of those functionalities that are unique to Avi when compared to NSX-T is the GSLB capability, or global server load balancing, which is what we're going to be using for this Horizon environment. And really what that is, if you're unfamiliar with GSLB, is the ability to kind of have Avi host a DNS record and load balance across sites based on DNS, rather than having to understand IP addressing and things like that and health checks across sites. So we're going to distribute 2 controllers across multiple sites. We're going to sync those controllers with each other, and we're going to use GSLB to provide a single URL for users to access the Horizon environment. So the users don't actually have to be aware of what site they're logging into. They don't even have to be aware of where their desktops are being instantiated, because NSX-T is going to be federating the policy across all of your sites. And Avi through GSLB is going to be providing a single endpoint for your users to access, so that whatever site is healthy and up, or whatever you determine as more suited for their use case, you can send those users there using GSLB. Other features that Avi kind of really adds to the capability of load balancing is going to be advanced analytics and visibility. And we take a look at how Avi is able to portray the different data points that it has through that service engine when traffic is actually flowing through. It is very helpful for troubleshooting or diagnosing any sort of issues, not only with the network infrastructure, but also with the applications themselves. And we'll take a look at how we can use that advanced analytics and visibility tool suite within Avi, and how we can go ahead and kind of diagnose some issues in our environment, or prevent foreseeable problems that we kind of build trends on as well. So to kind of put some nomenclature to some of the terms I've been talking about specifically for Avi, we'll talk about the architecture and what we're going to be taking a look at. And the first part of this architecture is going to be that controller cluster that I mentioned earlier. And this is kind of one of the largest differentiators between Avi and the other load balancing vendors out there, is this idea of having a disaggregated control and management plane from your data plane. So Avi is built in a way that it can service, it's deployed in a way that is a cloud native based methodology, and that your data plane and control plane are not on the same box. So when you deploy a control plane, that is your single source of truth. All configuration and all manipulation of your data, or whatever policy you're trying to invoke, will go through that Avi cluster. And then that control cluster will then push it down into the Avi service engines. So each service engine is going to be essentially the data plane realization of your load balancing infrastructure. And this is going to be essentially the actual load balancers that are deployed from Avi's perspective. So the goal here is that you never actually log into a service engine. So you never have to actually log into a single load balancer instance offhanded. You will always log into the centralized control cluster and manipulate all your service engines or your load balancers from that perspective. So, and kind of to enforce that, the Avi service engines really only keep their configuration in memory. So if they are considered disposable assets in the environment, and this kind of lends itself again to that cloud native development philosophy within Avi, in that because these Avi service engines are somewhat they gain everything they do is only influenced from the object controller specifically. This allows for things like dynamic scalability, whether that's scaling up or down. And essentially what that means is we're able to, based on load, as load increases, you can determine different metrics to allow your load balancing infrastructure to actually increase as data increases into the environment. And then once that data slows down, or that influx of traffic slows down, it'll then scale back into your minimum settings of load balancers across the environment. The final step that we have, or what we're going to look at, is our virtual services within this environment. And those are essentially the abstraction of the actual applications that you deployed in your environment. And what we're doing is abstracting those applications and distributing them across the physical or virtual service engines as they see fit. So when we take a look at virtual services within our environment, this is going to be the actual location of the virtual IP address of which your users or your whoever's consuming this application will be interacting with. And so this is where you can apply a lot of those different policies as far as, you know, your WAF implementation, or how you're actually going to, what are their backend services, backend servers that you're connecting to. And those virtual services are then instantiated on top of service engines to kind of realize that actual tangible data flow. And so overall, what we're taking a look at here is the main points to reiterate here is that we have a centralized cluster for control. That centralized cluster is the single point of management and control, whether that's through the GUI or API or into other cloud vendors for integrated services like, you know, DHCP and stuff like that from wherever you host your controllers. And that is going to push all the configuration down into your Aubrey service engines, which are basically the instantiation of the actual load balancers. And those load balancers are, like I said, held in a manner that they are reusable and that they're redeployable at any moment. So no single service engine should be a unique entity in your environment. And this goes back to the idea of you are taking care of cattle, not pets. Your load balancers are essentially treated like cattle here. So you build your configuration, you build your applications into virtual services, in your control cluster, and then it deploys those to however many service engines are necessary to meet what you need for your application. And again, that is dynamic and scalability. So it gives you that full range of control over how your environment is built and how it actually reacts to traffic flows as you see on a day-to-day basis. So kind of looking at the specific features we're using in this environment to deploy this Horizon VDI infrastructure across multiple sites. The first one we're going to take a look at is NSX-T multi-location, and specifically we'll be looking at Federation. Essentially what we're doing here is each site, and in our deployment we'll have two separate sites. We have two sites that each have their own NSX control plane. And we have one hierarchical control plane above that, which acts as an orchestration layer to sync sites together and also centralize and deploy configuration from what's called the global manager up top and deploy those to the sites per region or per location or wherever you have your local control plane for your NSX-T environment. So each environment will be able to run independent of one another, because they do have their own dedicated local echelon of NSX-T managers. However, you can go ahead and centralize all the configuration across multiple sites using the global manager to sync everything together and provide unity across all of your different locations. So what this actually means in deployment, in a deployment like Horizon, you might not be, it probably won't be necessary to stretch layer 2 configuration across site, which is another functionality you can get out of Global Manager. But a lot of people would like to be able to at least stretch the security policy across multiple sites. So the identity firewall aspect of this will be local to each site, because that will be, you know, as a users log in, the assets they're trying to access will be local to each site. But you may want to invoke security on the virtual machines themselves or the actual network fabric, and you want that to be uniform across all of your different locations. So we're going to take a look at how we can use NSX-T Federation and specifically this global manager to have a single point where we can create security policy, group all of our assets together into regions and different asset tags, or however you're grouping assets today. And then how we can invoke security on those objects, as well as create network objects if you were to want to, you know, stretch layer 2 across or provide local ingress or local egress per your site based on routing metrics. So essentially what I'm getting at here is NSX-T Federation allows you to control all of your sites from a single pane of glass from NSX-T Global Manager, that then pushes down to each site, which also hosts their local control plane in those locations. So how are we going to be using NSX-T Advanced Load Balancer, or the NSX ALB in this environment? So coming from left to right, we can see we have all of our users when they're logging on to, and they're trying to reach a Horizon desktop. They're trying to go to work for the morning, and they're trying to go ahead and access the resources they need to get their job done. Whether they're on a tablet or a laptop or a phone, they can use a web-based access method to obtain to get into their Horizon desktops, or they can use the thick client, which we'll take a look at. They might be accessing it from internal to each one of these sites, or they might be accessing it from an internet-based site from working from home, more commonly today. So to make it easier on them, the goal is to provide the easiest, seamless way to provide the resources that your employees need, or your consumers need. And so in this case, we're going to start out with GSLB. So we're going to deploy a DNS subdomain that's going to be controlled on our Avi controllers. And those are going to host a GSLB based URL that's going to be kind of load balanced between both of these sites. So if we look at both of our sites, we see that we have a controller at each site. So much like in NSX, how we have a local control plane at each site, we'll do the same thing with Avi. And those controllers are going to sync up with one another directly. So rather than having a higher level of orchestration like a global manager, in Avi's instance, in this case, our use case we're using here, those two sites are actually going to link directly with each other. And what's going to happen is they're both going to host the GSLB endpoint. So when a user attempts to go to this, in this example, a.gslb.horizon.com, they'll be based on the DNS resolution, which is going to come from the Avi controller itself. They're going to be sent to one site or the other. And each site is then going to have a service engine that's built out. And within that service engine, there are going to be different virtual services that are connected to either UAGs, or the Unified Access Gateway, if this is going to be hosted in a DMZ, or you can have that directly connected to your connection servers to give users access. And the connection servers will then bridge your users into their actual VDI desktop. And then from there, all their traffic will be managed and secured by NSX-T as their virtual desktops are deployed on the NSX-T fabric. So this is all a way of explaining of what I have in my environment and what we're going to take a look at. So the next step is really just to go take a look at it and see what we can glean from looking through the different UIs and how this is actually configured. So we're going to start from the infrastructure perspective, and then we'll jump into an actual desktop and see the user experience of deploying it, what they would actually see as they're trying to access their remote desktop. And so from this perspective, I'll start off with NSX-T. So where I'm logged into right now is I'm logged into the NSX-T Global Manager, and we can see that in this Global Manager, I have two sites. In this instance, I have a site in Austin and a site in Sioux City. And so this Global Manager is, like I said, what it's doing is going to go ahead and be able to give you a point of reference or a point of management that you can then deploy policy across both of these sites without having to log into one individually. However, if you need to log in individually, you absolutely can just by clicking on each site as you would need. So we look at the kind of some of the power of what you get out of a global manager. And the first step is to kind of organize your different sites into what we call regions. So you can see there's several default regions here. We have just the name of the site, and we have the global, which contains both of our sites. But if you have dozens or perhaps more than that sites, you might want to start breaking them out by different category. So for example, I've created a Midwest site here, which includes my location at Sioux City. And then I have a Southern site here, which includes my site in Austin. And so what this is really saying is that based on regions, I can now determine policy as it's deployed based on location, based on locality of what needs to be deployed. So for example, if in your Horizon environment, in Austin, users who access their environment there are allowed to access certain resources within the Austin data center, then you can allow that and have it specified to that data center there. And likewise, if you have some other policy that's unique to Sioux City, you can deploy it specifically in that region or in that site. And additionally, if you have something that is going to be global for your entire environment, you can obviously deploy that to your global environment so it's synced across all sites so that you don't have to worry about the location of where your users' desktops are being instantiated. You know that that policy is going to be located at each site across your entire fabric enterprise-wide. So to take a look at some of these groups that we can create, in this example, I've created two different groups here in the global balancer. And what this is going to do is allow me to group together assets on a site-by-site basis. And so in this instance, I have Horizon Site 2 VMs. And so what I'm doing here is really just grouping together all of the VMs that are going to be instantiated for my virtual desktop. And this is specific to the Austin location. And I do the same thing here for my Sioux City location as well. So what this is doing is basically just grabbing the group definition based on the criteria of the actual virtual machine as it's instantiated. And that's kind of one of the benefits of using NSX-T for your network fabric, is that because it is connected to your vCenter, it's able to glean the information from vCenter from an asset management perspective that you can then invoke policy, not on IP address or not on different attributes that are arbitrary to the application you're running, but you can actually build applications, application groupings based on what the application is, what operating system it is, and other characteristics that are a little more meaningful rather than the IP address or things like that. So now that we have these groups in NSX-T, I mean, what's the next step? What do we actually do with this? This is all great. The next step is we can do things like apply a distributed firewalling for those specific groups, or north-south firewalling for those specific groups. So taking a look at just some example rules here that we have for my distributed firewall. What I have is two different rules, and they're very simple, just ingress allow all and egress allow all for my desktops. And so what I'm doing here is actually applying this to a global level. So I'm applying this to all of my sites. And I can break this out specifically by site. And I'm just applying those two groups. So any traffic, anything that is sourced and destined to whatever is inside these groups, and these groups are site specific, I'm going to allow that traffic. And the same goes for this egress allow all, the same concept. Anything sourced from anything in these groups, which are again site specific, accessing anything, I'll allow that as well. So you can get as granular as you want on a site by site basis. We can do another rule that allows that sites aren't allowed to talk to each other, or that specific sites can access certain resources that other sites can't, and likewise. So we can do this on again, on a site by site basis, on a cluster by cluster basis, a VM by VM basis. And when we're talking about the local managers, we can even do it on a user identity basis, which again is a talk that we had last week about the NSX-T identity firewall. So from an NSX perspective, that's what we're kind of working with here. So we have both of our sites federated across. So we have policy being created at both of our sites in one central location. If we add more sites to our environment, we can simply add those sites into this global manager and go ahead and apply all the same policy rather than having to rebuild from scratch and understand what we did previously. Another big benefit of this is that all of these things that I'm kind of showing you here are all context aware. So I'm not showing any arbitrary IP addressing or anything like that. Although you can, if that's the method that you want to choose. Everything here is going to be based on contextual information, so you don't have to do the whole scramble of finding what IP address went to what when someone created that rule however many years ago. So now that we have our NSX-T fabric built out, the next step is going to be our AVI controller. So how do we get traffic into this environment? So we have our Horizon environment built out. We're using NSX-T to link our two sites and build out that fabric. We have our NSX or our Horizon controllers at each site. Everything's ready to go from a network perspective and from a Horizon perspective, but how do users actually access this? And so that's where we're going to use AVI to actually jump in here. Let me log in. Learn how to type. And so now we're looking at an AVI perspective, and there's a few different ways to view an AVI configuration. So we're logged into a controller, and this particular is my controller at site 3. But as we saw in that diagram previously, because we're using GSLB, we are linking these sites together. So they are sharing information specifically to GSLB to understand site health, to provide a endpoint for the for that GSLB URL. And so we're going to start from the top going down. So we're going to start with our GSLB configuration here. So we can see here that in this GSLB configuration, this AVI deployment is the owner of this subdomain in my sterling.lab. So gslb.sterling.lab is hosted by my AVI load balancer here. So it actually is functioning as a DNS server in this instance. And we have our two sites here. So we have two different control nodes that are deployed at each one of these sites in a highly available cluster. I can see they each have their own DNS service, and both sites right now are looking good and they are in sync with each other. So we can see that I have the management access to each one of these, and they are in a continuous replication set. So that is the GSLB setup of this. Now we can see how both my sites are linked together through my network fabric in NSX-T, and now we can see how the ingress control for my network is also controlled in a disaggregated fashion using Avi and a GSLB. So the next step here is in the infrastructure component is we'll talk about our service engines. So these service engines are the actual instantiation of the load balancers. So any sort of VIP or any user traffic that's actually being generated to access my Horizon environment is going to be going through these actual load balancers here, or these what are called service engines in Avi. So these are the actual objects that I was referring to earlier, as these are not necessarily unique by any nature. These are deployed as virtual machines or on bare metal, or again, on any sort of public cloud you may be dealing with. They're controlled by a central control node, and they are flexible and dynamic in how they run. So the configuration on each one of these service engines is held in memory, and it is only deployed to them by the centralized controller. So you're not going to be logging into any of these load balancers to do any sort of unique configuration. Every configuration point is going to be done from the control cluster and then pushed down to your service engines. Again, if we just kind of look at some of these different things, if we look at this default group here, we can see I have my two service engines here. This is what's going to be actually hosting for my Horizon. And then I have another service group that's actually hosting my engines that are running the DNS service for GSLB. And if I look at one thing I want to point out here is the different way you can kind of deploy these. You can do them in a legacy type model of active standby, which is Avi doesn't usually recommend that. That is a legacy way of doing load balancing. So more often than not, you'll do an active, or you'll do a node that's active plus a buffer node that is in a follower state. But what I like about Avi, and something that's unique to Avi and how it handles traffic, is this advanced HA and placement policy you can build out here. So what this is actually saying is that using this policy, you can dynamically scale virtual services based on virtual service. You can actually scale your service engines based on virtual service traffic to a minimum and maximum based on the actual load that it's seeing. So if you run into a situation where you have dynamic traffic availability, or you have something, say on the weekend, nobody's logging into your Horizon environment, so you don't necessarily need all of those service engines running at all times, you can use Avi to dynamically scale that back down. And then Monday morning, when users start logging on to maintain the quality that they expect or the experience they expect, Avi can dynamically start creating more service engines to spread out that load across them all. So we've looked at the GSLB configuration of how the two sites are actually linked together. Then we took a look at the actual service engines and how the service engines are built out. So we have 4 essentially load balancers in this environment. And then we'll look at how does that look from the application perspective? So all we talked about so far with this is all infrastructure. We're all talking about how are we linking these sites together? How are we making policy across them? And what's the management like of this? So the last piece of this is the actual application itself. And so in Avi, the way you kind of visualize your applications is going to be typically through virtual services, which are actually instantiating the endpoint that your users are going to be at the end reacting with. And so if you look at this, this is a point where all traffic, this will show you all traffic that's actually going through your environment. So this is what comes into play when we talk about that advanced analytics and advanced visibility into your environment. And this doesn't just include the ability to see, TCP dumps or traffic at a time. This includes historical data that's not just relevant to the load balancer itself, but also the application. So we can see here that what I'm seeing is an application map, and this is showing the full-time latency from a user, from a client, and accessing the application and how long it actually takes. So if you can see, different spikes, you can see we had a dead period here, and then, users started logging on, and you can see that the different load is as it was going out throughout the day. And we can see within this chart, the different components that were alternating throughout the day. So if you start getting user requests saying, hey, I'm getting a very slow experience. I'm for whatever reason, I click this button and it takes forever to load. The wheel just spins. You can come in here and see, okay, when they did this, what aspect was actually taking the longest time, or what am I actually seeing as far as traffic flows? So we can see how long is it on average taking the client itself to actually reach the load balancer VIP. So we can see my client to my VIP took 34 milliseconds. We can see the actual VIP to the server within the server pool. So this is the actual connection server in this instance. We can see that takes about 1 millisecond to actually access it. And then the application to actually respond back to my load balancer, which is proxying this connection, is going to take about 36. We have a total of about 81. So if we see any sort of anomalies in this, for example, if we see this spike here, we can see that in this instance, it took much longer for the data to transfer from the application perspective. So we can see that all by and large, we can see that this might not be an issue with our network per se. This could be an issue with the application. Perhaps it is a link they're trying to access that is a dead link, which is exactly what I was doing in this instance. And we can use this to kind of dig down and see where is the actual issue in our environment without just shoving the blame into the network and expecting, TCP dump and other analytics are a little more arbitrary without context to figure out the actual issue. And if we look even further into this, not only can we see the overall view of how data is being transferred in the environment, we can see each individual request as it comes through. So this morning I went through and did a few just request connections over to the Horizon connection service, which is going to traverse this service engine and this virtual service here. And we can see how in depth this gets. So I can actually take a look at this and break this out and see on this exact request here at this exact time. So if you have a user that's saying, hey, I'm getting this issue, it's no longer an idea of trying to find the average user. If there's a single person having problems, you can go ahead and see exactly how they're built out, what security protocols they're using, if they're using things that are trusted, what is the actual URL that they're trying to access here. In this case, this is our GSLB managed URL. And we can see everything about this from the granular aspect of being able to determine what actually happened. And so in this instance, we can see that, this is one of the ones where I was trying to connect to a URL that doesn't exist. And we can see there's an abnormal event, 0 window to server. So it's really saying the server wasn't sure how to react to this particular request. And so it took a while to respond with an error, is what the instance was here. So you can take a look at this granularity we have in information. And there's an entire list that we can go on for days and talk about how you can actually see what's going on in this and what sort of analytics you can grab. And this, again, is all just from your load balancing platform. So this is taking load balancing to another level. And what this is doing, again, going back to that idea of having that decentralized decentralized data plane and feeding all this information from the service engines back into a centralized control plane ensures that you're not overloading your actual data plane with analyzing this data. So your actual service engines are not taking this information and compiling it and putting it in a readable format. Your service engines, which are the data plane of your environment, are exporting this information into the control plane, which is then scaling. You can scale that independently. And that is actually the part that is using the analytics for all this data. So you don't have to worry about log ingestion or log analytics bringing down your environment from a data plane perspective. You might have bottlenecks in your control plane, which you can scale it independently, but at least you don't have to worry about something silly like, you're getting too many logs and that is going to bring down your data plane. So they're mutually exclusive in that instance. That's just another benefit of using Avi as kind of like your software-based load balancer in your environment. So finally, after we've talked about everything essentially from the infrastructure perspective, we've seen how NSX is molding the sites together. We've seen how Avi is providing a single endpoint to reach our Horizon environment. The next step is to go ahead and log in to the actual environment. I just wanted to show you just real quickly. Again, I wasn't trying to focus on so get this over here on Horizon specifically. This is more about the infrastructure deployed to support it. And so if I go ahead and look at this, I can actually disconnect from this. And so from a user perspective, what they're going to end up doing is connect to their Horizon client. And I've added in a new server here. So when they add a new server, it's really just going to be that GSLB URL. So again, from me logging in as a user perspective, I don't know what site this is going to go to. I just know that I need a Horizon desktop, and this is the site I connect to. So I'm going to log in with my normal Active Directory credentials. And then I'm presented with whatever access I'm allotted. So in my case, from an administrator perspective, I can build desktops in either site. And again, both these desktops would be deployed on NSX-T using a federated policy. So regardless of which site I choose, I will have the same security policy applied to my virtual machine or my virtual desktop. But from there, I log into my desktop. It'll go ahead and build this out, and I'm off to the races. And from a user perspective, it doesn't matter if a site goes down. If site 3 goes down, I'll just go to site 2, and likewise. And if I add another site to this environment, again, the users don't have to change anything from how they're actually logging in. They're still logging into a single URL. And then they're presented with whatever options you as an administrator determine that they should have access to. And so this is the first time I'm logging into this one, so it's going to take a little bit. But I just wanted to show that as kind of the infrastructure build out, and then what is the result of that infrastructure build out. And again, we're using NSX-T to mold sites together. We are using Avi as that single endpoint. And then the result is our users have a seamless experience to accessing the virtual gateway or their virtual desktops. And again, your user doesn't have to know what site this is. It's not really important to them. They just know that they want to be able to access certain assets, and you want to be able to manage them as they do that. So let me get this back up. So as a summary of what we just talked about, I just want to reiterate a few of the different points. We're using Horizon here to provide that virtual desktop infrastructure, as a remote capability for your staff, for your users, for your consumers, or your applications, anybody that needs access to your data center, or anybody that you would like to consume data center resources. In order to facilitate access and control of Horizon, we're using NSX-T as the network fabric. We're deploying this across multiple sites. So we're using NSX-T to bridge those two sites together from a network and security perspective. And then we're using Avi or NSX-T Advanced Load Balancer to provide a single endpoint or a single gateway into both of those sites, or however many sites you deploy for your environment, as well as a visibility suite to understand what exactly is going on with the users. How are they actually being what sort of experience are they actually seeing as they traverse our virtual services and our actual service engines? Avi is going to take care of that dynamic scalability. So again, like I mentioned earlier, if you have a flux of users every Monday morning, Avi can help you scale out that environment and scale back down to recover resource utilization. And again, everything here is going to be built in such a way that is site independent, and security policy will be spread across everything as needed. So with that, that's everything I had to present for today. So if anybody has any questions, we can go ahead and talk through those now.
Yeah, Billy, we do have 2 questions here. So the first one is, how does Avi scale load?
Yeah, so as I mentioned before, that's part of that dynamic scalability aspect of the service engine. So the service engines themselves act as the load balancers, and the virtual services are deployed across those service engines. And so because Avi is getting the analytics from CPU utilization or RAM utilization or certain traffic count or whatever metrics you determine you want your application to scale, and that can be based on experience, and you have to kind of fiddle around with what experience is best suited for the load balancer utilization. And then Avi can go ahead and scale based on those metrics, and it will scale the actual load balancers themselves if needed. Hopefully that answers that.
Great. Yeah, and we have only one more question. So what happens if the controllers go down?
Yeah, and so this is going to be a situation where there's different ways that controllers can go down, but the point of this new model of deploying management and control plane architecture in the 3-node kind of quorum-based model is that previously you would have 2 controller in a legacy model. What a lot of vendors do is you have an active and a standby. And in that instance, the main crux of that problem is when you have one active and one standby and they're synced together is a split brain scenario when you lose network connectivity between the two. And that's very common to happen across an environment that is across multiple sites. And so what Avi is going to do is deploy those 3 controllers, and we can deploy 3 controllers at each site, so that if any one of those sites actually go down, as long as there are 2 nodes in that 3-site solution, they still maintain quorum. They're still aware that they have the latest state, and they're still aware of who is the leader and who are the followers in that environment. So rather than having an active and a standby, it is a leader and follower type of approach where everyone is actually active. They just need to maintain quorum. And because that control plane is actually not a part of the data plane, if your control planes totally get blown away, your actual service engine still maintain the configuration they had in memory. So nothing actually changes from the user perspective if you lose, all access. You couldn't make any changes until you redeploy your control plane if a catastrophic event occurs, but at least your data plane is still running at the latest known configuration.
Awesome. And we did have one more question come in around Horizon client access. Can the site choose or recommend which site to connect to based upon whether site is down, or better yet, recommended one with lower latency?
Yes. So GSLB can also function through latency-based metrics. So you can do geolocation-based metrics. So if you want users that are living in the south to access your southern data center, or living up north to access your northern data center, that can be taken into account into how DNS is actually divvying out that address. And essentially how this works is when you go to that, in our instance, when we go to that horizon.gslb.sterling.lab URL, it is going to be resolved through my Avi controllers, and the Avi controllers are going to make that determination as to which site is more valuable or more kind of makes more sense for the user to access. In my deployment, I did a simple kind of round robin type of way. So, it would just kind of bounce back and forth. But if one site would go down, the point of GSLB is that single URL is now aware of a site outage, and it will shift all traffic to the known good site. But yeah, you can also incorporate other more advanced policies to determine traffic flow from the GSLB perspective.
Great. So that is all the questions we have. Billy, thank you so much. And thanks everybody for your time. If you have any follow-up questions or joined late, please reach out to any of these email addresses you see on the screen here, and we can either get you the recording of the demo that we did today or answer any questions you have via email. Thanks so much and have a great day.
Awesome. Thank you.